For most of the labs we do this semester, it's just one lab. Everybody works on it together. You just submit one thing. Everybody does the same thing. The first lab is a little different because there were no great, like awesome labs available dealing with waves, but there were four pretty good labs dealing with waves. Here's the way I do the first lab. There are four different applets I want you to play with. Everybody should go in and play with all four of these. Then decide as a group who's going to write about each one. So everybody just writes about one of them, take some screenshots, write up some text. Basically, you're just playing around and like I'll show you exactly what I'm talking about. Everybody writes about one, decide as a group who's doing what, throw that all together into like a Word document or a Google Doc, save it as a PDF and upload it. Okay, so like here. Here's one of the four possibilities. So here I'm looking at from above water dropping into some tank. And I can see the bright spots are the crests, the dark spots are the troughs. So I could get out my little measuring tape here and I can measure the wavelength. Wavelength is the distance from one crest to the next. And I don't know if that's perfect, but you can get the idea there. So based on how quickly or how quickly this thing is dropping water, that's my wavelength. Wavelength is the distance from one crest to the next. I could get out my timer here. Oh, I got it paused. So, and go boom, boom. Roughly, that was my period. Period is the time from one drop to the next. I could look at this same view here if I wanted sideways. Ah, here we go. Side view. So there's a wavelength is the distance, period is the time in between drops. And so what I would do is now take some screenshots, play around in here, maybe change the frequency, change the amplitude, maybe produce a graph. Just go in here, play around, take some screenshots, and then write a couple of sentences about each screenshot. Hey, you can see here that the wavelength is about 2.6 centimeters, and so forth. Just using the terminology from this week, take some screenshots, play around, write some text. And if we start over, we could do the same thing with sound. We could do the same thing with light. So that's that applet. Then we got wave interference. So now I can have two of them running. And these waves are interfering with each other. So I've got two waves coming in right there at that spot. Two crests happen to meet up at that spot at that time. That's called constructive interference. So that's twice as big as one individual wave would have been. Right here at this spot, where it's really dark, that's two troughs combining together. So it's really low. It's twice as low as what you would normally get. So you look right there. And these spots right there where it's just kind of dull looking, that's where one crest happened to match up with one trough and they cancel each other out. So my amplitude there would be zero. So same game here, get in, play around, make some measurements, take a bunch of screenshots, write a little text about each. Here in this app, we're looking at normal modes. So we'll make this thing oscillate. And if I If I pick the frequency and let's put no damping on. If I pick the frequency just right, I can make this green dot right here in the middle look like it's sitting still. That would be a normal mode where it just looks like the whole thing is waving up and down, probably in 2 or 4. Let's see if I can make it do it. Let me restart it. Oh, whoa, that's way too fast. So you got to kind of get in here, play around, try to produce normal modes. I don't know if you need to watch me sit and play here. So watch the videos on normal modes. That's your goal here, is to produce normal modes. Again, play around, take some screenshots, write some text, and so forth. And then this last one, I wish we had time this semester to get into stuff like Fourier analysis and signal processing. This is one of the ways waves are used in the real world. You got your favorite song, right? You probably listen to that song on Spotify. So that song was recorded analog. A guitar was literally playing sound waves that was then converted into digital. The way we do those conversions is through something called Fourier analysis, typically the fast Fourier transform. Just kind of build something here and you can see. Okay, so you've got some sound wave. So this is maybe a singer is singing some sound wave and it's oscillating. It's got some weird looking oscillations. What that sound wave is, or another way to think of that sound wave, is this can be broken down into a whole bunch of sines and cosines added together. So look at this guy here. That would be the fundamental frequency. If the singer is trying to sing an A note, 440 hertz, for example, this is the main note you're hearing there. But there are a bunch of harmonics on top of that. So this wave here has this much of the fundamental frequency, and it has this much of the octave. This would be twice the fundamental frequency. And if I alter that, if I change that, see how it changes that sum down at the bottom. And it has -1 of this and 0 of this and so forth. So what the way I'm building this is I'm taking a bunch of individual sine and cosine waves and adding them together. The way Fourier transform works is going backwards. You start with something like this, and we decompose it into a sum of a bunch of these guys. And then what does your computer store? It just stores these coefficients. So at every moment in time, it's just got a list of numbers. That's how songs are stored on the computer. Just a list of these. I don't know how many they use, probably more than 11. But for every moment in time, there's this list of numbers, and those represent the amplitudes of different versions of sine. And adding all those together, you get the original sound wave back. So you'll come in here again, you're just going to play around, take some screenshots, write a little blurb about it. Everybody does one. Everybody should play with everyone. Everybody writes about one, squish it all together into one document, submit it as a PDF. I think for this one assignment, it will even let you submit just even a Word doc. Usually you always have to submit a PDF. I think this one allows any kind of document. Like, let's see. No, it does want a PDF.